Hi Falcons, this is Mrs. Lamb from Team 7 Silver, and today we're going to be doing lesson 3 in your book on page 17. We're going to start on part 2 of this lesson 3. So it says that two students are solving the same problem. At a hardware store they can cut a length of rope off of a big roll, so you can buy any length you like. The cost for 6 feet of rope is $7.50. How much would you pay for 50 feet of rope at this rate? So Kieran knows he can solve the problem this way. He knows that if 6 feet costs $7.50, he wants to know what 1 feet would cost. So he has to multiply by a sixth or divide by 6. Right? This is your scale factor. He's dividing by 6 or multiplying by a sixth. So when he takes $7.50 and does that, he gets $1.25. So 1 foot of rope would cost $1.25. This is my constant of proportionality, right? We are multiplying by $1.25. So if I want to know what 50 feet of rope would cost, each foot of rope costs $1.25. So I'm going to take 50 times 1.25. And that tells me that that would cost $62.50. Okay, so what is Kieran's answer? $62.50. And we did that by taking, so you remember, 50 times the constant, or 1.25. Now Kieran wants to know if there's a more efficient way of solving the problem. Priya says she can solve the problem with only 2 rows in the table. So how is she going to cut down on the 2 rows? What do you think she did? Well, Kira found the constant. She took 7.5 and divided by 6. And that gave her $1.25, which she can now, she knows the price per foot, she can take that times 50 and get the $62.50. Okay, so again, let's write down what Priya did. Priya took $7.50 and divided it by 6, which was $1.25, her price per foot, and took that times 50. She's essentially still doing those 2 steps. She just did them all in one fluid motion in her calculator. She took the price divided by the foot, 7.5 divided by 6, which gave her the constant, 1.25, which she took times 50. All right, so now we have a new problem: swimming, manufacturing, and painting. Tyler swims at a constant speed, 5 meters every 4 seconds. How long does it take him to swim 114 meters? So again, I'm going to find that constant. I'm going to do 4 divided by 5. Which gives us 0.8. And do you remember that second step? Now you're going to take that number and multiply by 114, and you get 91.2 seconds was how long it would take him to swim that. Okay, our next problem. A factory produces 3 bottles of sparkling water for every 8 bottles of plain water. How many bottles of sparkling water does the company produce when it produces 600 bottles of plain water? Okay, now they haven't filled in our chart for us at all, so we're going to have to do that. A factory produces 3 bottles of sparkling water. Okay, so I put my 3 here under the sparkling for every 8 bottles of plain water. So for every 3 sparkling, I have 8 plain. How many bottles of sparkling water does the company produce when it produces 600 bottles of plain? So I want to make sure I put that in the plain column, the 600. So I'm looking for an empty spot on the other side of the chart this time. So if I look for my constant, again, I do y over x, so it would be 8/3. But remember, we're not filling in. If we knew this number, we would multiply by 8/3 to get to 600, right? Our constant. But when you want to come the other way, remember we multiply by the reciprocal. So instead of 8/3, I'm going to multiply by 3/8. So I take 600 times 3/8, and you would get 225. Now, I always do a little check. If this number is smaller than that number, then in this row it needs to be the same. It should be smaller, and it was. So that makes sense to me. If I had multiplied by 8/3, I would have gotten a larger number, and then I could have seen that that didn't make any sense at all. Okay, so that's how I would kind of know if I'm doing it going in the right direction or the wrong. So this time we took 600 times 3/8 multiplied by the reciprocal. So on the last one, we have a certain shade of light blue paint is made by mixing 1.5 quarts of blue paint with 5 quarts of white paint. So again, let's make a little table. We have blue paint, and these are quarts, and we have white paint, and these are also quarts. All right, so it said when I have 1.5 quarts of blue paint, so 1.5 with 5 quarts of white paint. Okay, so I fill in my table. How much white paint would you need to mix with 4 quarts of blue paint? So here's my second row in my table. I'm going to find my constant by taking 5 and dividing by 1.5. And you get 10/3. So 10/3 is my constant. I multiply 4 times the constant to get the empty box. So 4 times 10/3. And you get 40/3. Now, this is probably going to make more sense if I go ahead and find the mixed number. So I'm going to, if I hit the second bar, I can hit fraction to mixed, this button right here, and then hit enter, and it will show me that that's 13 1/3. That was 13 1/3 cups. Quarts. Now, the last step of this. For each of the previous 3 situations, write an equation to represent the proportional relationship. So remember y equals, well, what is y in this case? You could put your x and your y on your table to help you. To help you remind you. So in the first case, y would be time. So we're going to say time equals 4/5 was our constant. So 4/5 times the distance. Time equals 4/5 times the distance. Let's look at that one again. Time, this number equaled 4/5 times whatever our distance was. That's what we did there. Or 0.8 is another way of saying 4/5. Okay, on B, let's look back at B. Here's our x, here's our y. Y was the plain water. So plain water equals, what was our constant? 8/3. 8/3 times the sparkling water. Y equals kx. Remember that? A proportional relationship can always be written in that format. And then on the third one, we had blue paint and we had white paint. So the white paint equaled 10/3 times the blue paint. 10/3 times the blue. So y equals kx. In this case, we had time and distance. We had plain water and sparkling water. And then we had white paint and blue paint. That's the W and the B. Okay, in summary, for today, I would like you, this is on page 20 in your book. It says if we identify, highlight this, or circle or underline two quantities in a problem, and one is proportional to the other, then we can calculate the constant of proportionality and use it to answer other questions about the situation. Okay, they're giving you an example here. Andre runs at a constant speed, 5 meters every 2 seconds. How long does it take him to run 91 meters at this rate? So in this problem, there's two quantities. We have time and we have distance. Since Andre's running at a constant speed, time is proportional to distance. We can make a table with the distance and time and fill in the given information. So again, if you do the division here, 2 divided by 5 would be 2/5. So 2/5 is my constant. And if I take 91 times 2/5, I can figure out that it would take him 36.4 seconds to walk the 91 meters. And that's approximately. And then if we wanted to write this as an equation, remember y is time, so we have time equals the constant, which was 2/5 times the distance. Today you will be doing practice problems. Starting on page 21 in your book, you will do 1 through 5. 1 through 5. Now set up a table for each one of these. I think the table will help you. Okay, and if you get to number 5, I want you to look at number 5 in particular. It says Crater Lake in Oregon is shaped like a circle with a diameter of about 5.5 miles. So how far is it around the perimeter? Well, if you remember, another word for perimeter is circumference of Crater Lake. So circumference, the formula is pi times diameter. And then it says, what is the area of the surface of Crater Lake? So the area, remember, is pi times the radius squared. So you should be all set to go. Thank you, Falcons. Have a great day.